All right, so looking at this question here, question 8, a motorboat dealer claims that 85% of his customers would recommend his boats to their friends. A student wanted to test this claim and decided to ask the dealer's customers. She found that 45 out of 57 of the customers' questions would recommend the dealer to a friend. Construct a 95% confidence interval for the proportion of customers who would recommend this dealer. So straight off the bat, we've got to go and set up our confidence interval. Now, we've done this. This is a simple part of the question. But I'll still write it out just because it'll help us with the next bit. So p hat minus 1.96 square root p hat over. So then we've got 1 minus the proportion sample again. So we got that as our lower bound. Let's just copy that to save ourselves some time. So copy, and then we're looking at our upper one here at less than equal to, and then we've got the same thing, but let's paste it just to save ourselves the time. Okay, so we've got this in here. You can also put this in your graphics calculator. I'm just putting the values in because it's going to help us later. So we had this proportion of 45 out of 57. So 45 over 57 minus 1.96 over 45 over 57 times by 1 minus 45 over 57 all over 57 trials, because that's our n, and then we've got the same thing as our last one here. Okay, so let's just copy this value and put a plus in there. So got that all in, and so then the next step here is we work out our actual confidence interval. Now, I'm just in my calculator at the moment, so 0.95. We've got 42 trials of 57, and this gives us a lower of 0.623, because we're going to go to 3 significant figures, and then we also go, our upper bound is 0.851. Now, does this support the dealer's claim? Realistically, yes, it does. The dealer's claim sits within this confidence interval, so we're 95% confident the proper proportion sits in there. I shouldn't have p hat on them. Okay, so yes, at the moment it does. It doesn't contradict. Realistically, when we're 95% sure it sits within this region, but you can sort of tell it's near the edge here. If we reduce the width, it won't sit there. So if we did more trials and the mean didn't change, we would find that this probably gets rejected out. So then it goes out of 57 customers. What is the lowest number of customers who would have to deny they would reject, they would recommend the dealer to a friend before the claim was rejected? So in this, realistically, we can take this formula up here that we've done. So this here was our formula. So if I copy that and we paste this here, okay, and I'm just going to change this to these 45s. We're going to change them just to a variable. So if I change them all to x's, so I've just picked x. I haven't picked x because it's in stats or anything. I've just picked this and x. X is number of people who recommend. So then 57 minus x will be number of customers who deny. Now, I would have written this out a little bit more fully if I was doing this as a proper question, because these claims are a bit like slow here. Now, realistically, what we need here, and if you look at this confidence interval, I need this value here, this 0.851, I need this value here to be less than 0.851. And then that will mean that my value is, then that will mean that I've got enough people rejecting it for it to be too low for that value. So I go x over 57 minus 1.96 over square root. Now, I'm going to times I'm just going to write this a little bit differently. So x over 57, and then we've got 57 over 57 minus x. And then this one on the bottom is 57 on 1, so this would just be times 1 over 57, just so I can get rid of that. Okay, and this has got to be less than equal to 0.85 if we're going to reject the claim from that. So, and you got to remember that this idea of rejecting the claim, this is only a 95% confidence interval. We probably can't reject the claim. We would just say this evidence doesn't support the claim. So straight off the bat, let's rearrange this. So rearrange this like an equation. So let's go negative 1.96 square root x over 57. Now I'm just going to do 57 cubed because I've got 57, 57, 57. And let's actually expand this bit out as well. So let's go 57x minus x squared. And this is going to be less than equal to 0.85 minus x over 57. Okay, so then we square both sides. So I'm going to get negative 1.96 squared. Okay, and then we're going to have this thing here. So 57 x minus x squared, the square root's gone now, over 57 cubed. And this is going to be less than equal to 0.85 squared. And then minus 2 times 0.85 times x on 57. Be aware that I did the negative at the start, and then plus x on 57 squared. Okay, we're going to move everything to the left so we don't have to deal with it as much anymore. So once we move this all over, we can actually solve this for a value. So we get here, I'm going to have to expand this thing out. I'm actually going to, let's just times everything. So this would be 57 squared. Let's times everything by 57 cubed as well. So I'm going to do two moves at once. So I'm going to times everything. So both sides by 57 cubed, which will just mean that goes. This here will be times 57 cubed. This here will be, that'll cancel with one of them, and this will be times 57 squared. And then this one here will just be times 57 because this will cancel there. So my next line here, I'm going to move that to the left. So that's got a positive sign. So it's going to be negative 57 x squared, which is this value here. So that bracket, I better delete that because that'll be a little bit confusing. So negative 57x squared, and then I'm going to have this value here. So that will also be, I'm just going to do plus 1.96 squared, and that's going to be times x squared as well. Okay, so that's got my final term here, and I've got rid of that x squared once it's multiplied in. The next one, we're going to add this to both sides. So I'm going to have plus 2 times 57 squared times 0.85. And then that's times x, and then I've got this other x value here, which is going to be plus 1.96 squared times 57x. So that's got rid of this value here and this value here. Now this squared at the start means that that's going to be positive. That's why I've just changed them to positives as I've gone through. Final step is our constant, which is going to be 57 plus 57 cubed. No, minus this, sorry. Minus 57 cubed times 0.85 squared. And then there's no constant over here. We've done everything. And this is all now because we've moved it all to the left. It's less than equal to 0. So we're going to just look at 0, and then that's going to give us 2 intercepts, and then we can work out those values. So I'm going to be a little bit lazy here. Realistically, you can put these. Let's actually. All right, let's just keep going. Actually, I was going to just put it in equation mode, but let's do this. So we've got minus 57 plus 1.96 squared gives me, this first value here is negative 53.1584 x squared. And then we've got plus 2 times 57 squared times 0.85. And then I've got that plus 1.96 squared times 57. And that gives me plus 5,742.2712x. So that's those next two values. So just multiply them out. Now, I'm writing the full decimal out, which we wouldn't usually do in a solution, but I just don't want it rounded yet because I'm still working through. Realistically, I could have kept exact values and put it in the graphics calculator. This next one, 57 cubed times 0.85 squared gives me 6,395, I think. 57. I've done that wrong. In my calculator, I knew that was too small. So 57 cubed times 0.85 squared. So I left that all up in the power. So this becomes 133,801.9425 less than equal to 0. So you got a few options here. You either graphics calculator it and you put it in the equation mode, or you graph it. If I graph it, I think I've actually got this value already set here. Why is that not graphing negatives? No, I've not quite done that right. 5,060, 53.1584. Okay, I'm looking for, let's put this in equation. The graph is not showing properly. I'll need to check that out later, but we're looking at polynomials, degree 2, and I've got my values in there. I think I've stuffed up this first value because 53, I don't know why I've done 50. 52 and 41. Okay, this value here I seem to have stuffed up, I think. So I'm just going to see whether it gives me the correct 0.1584 574 1. Okay, solve that. 74 and 34. I've stuffed up this value here and I'm trying to figure out where it is. But this is the way you do the solution. I just trying to figure out what I've done there to give me that value. And what do we have? When that comes over, we would see 57 x squared. And that becomes positive. Last time I moved this to the other side and that became positive. I think one of my issues might be I've lost this negative here when I've expanded. That's where I've stuffed up that. When you multiply out with that x squared, that's a negative, which gives me a value of, when I go back, not plus, I got minus 1.96. So that gives me 60 point, this value here has to be, 60.8416. So we've got that there. So now when I put that into my graphics calculator, I get polynomial degree 2. I'm just going to put that in there, 60.8416, and it gives me values here of negative 60. One side, negative 60.8416. And when I solve it, it gives me an x value of, this solves for x, let's do the proper x. X equals 52.45 and x equals 41.92. Now this is interesting because you get the two solutions, and what you actually end up here with is these are actually the two. This high number is when you actually move the confidence interval, and the lower bound will exclude that 0.85 as well. The reason is because when we squared both sides to simplify it, you actually achieve this side being less than equal to 0.85, but also this side being greater than equal to 0.85. So this is the value we want. So we've solved this. This is the value we want here. And so we need, realistically, if you think about the confidence interval, if 42 people say it, it's going to be too high. We're rounding up. So this number here will be above this number. But if we round that down to the next person, we're going to find that's correct. So x equals 41 people, and that's x equals 41 people that recommend this. Therefore, 57 minus 41 equals 16. 16 people reject. Not reject, sorry, 16 people do not recommend to a friend, and that means you have evidence that you could talk about rejecting the dealer's claim. You can't definitively reject it because remember 5% of the samples you take would achieve that. So if in this, because we've got a 95 confidence interval, that means when we do 100 samples, 5 of those would contain a population mean outside of this confidence interval. Okay, I'm going to finish that there.